In a Harris poll of 514 human resource professionals, 45.9% say that body piercings and tattoos were big grooming red flags. Use a 0.01 significance level to test the claim that less than half of all human resource professionals say that body piercings are big grooming red flags. Assume we already did the first step of the hypothesis test and determined that the null hypothesis is p equals 1 half and the alternative hypothesis is p less than 1 half. Compute the test statistic for the hypothesis test. We do not need to carry out the complete process of hypothesis test. We just need to compute the test statistic in this case. First, when we read the question, we should summarize these numbers in symbolic form using statistical notation. 514 human resource professionals is the sample size, so this is n equals 514. 45.9% say that body piercings and tattoo were big grooming red flags. This 45.9%, we assume that they computed from the sample, and so p hat equals 0.459. It is the proportion of the sample. The significant level is alpha, so alpha equals 0.01, but in this case we will not need to use it because again we only compute the test statistics. The test statistic for the hypothesis test for the population proportion P is Z equals P hat minus P naught over the square root of P naught times 1 minus P naught over N, where P hat in this case is 0.459 and P naught is the null value. It comes from the first step. It is the number in the null hypothesis, which is 0.5. 1 half is 0.5 divided by the square root of 0.5, and 1 minus 0.5 is 0.5. In this case, we already computed because we don't want to write so many numbers in this expression. P naught is 0.5, so 1 minus P naught is 1 minus 0.5, which is 0.5, divided by N is 514. We then plug in this into a calculator. Do not attempt to do this by hand. The calculator should give us negative 1.859. And this is what we call the test statistics. But what is the test statistic that we just found? When we perform hypothesis testing, we rely on sampling distribution. In this case, we determine that it is the left-handed. Remember that the assumed null hypothesis is p equals 1 half, and from the sample, we found that the proportion from the sample is p hat equals 0.459. And so the test statistic z value is simply a number that will standardize these values to see how far the result that we obtain from the sample is from the assumed null value. As of now, we cannot compare these values because the scale. But after we standardize these, recall that anything that is within 2 standard deviations away from the mean is usual, and anything that is outside of 2 standard deviations away from the mean is unusual. And this standardized value, this test statistic, will allow us to determine how extreme such a value that we obtain from our sample. The further away from 0 this test statistic is, the more unusual it is for us to obtain such a sample.